Okie dokie, hokey pokey. Section 2.5 Marginal Cost and Revenue. Okay, so now that we've talked about um, the cost and the revenue function, and now we've also talked about derivatives, we will take derivatives of the cost and revenue functions. And so we will be combining everything that we've talked about. So the nice thing about this class is that it's not a whole bunch of disconnected concepts. Everything that we talked about, we'll use it. So it all builds on itself. So that's good because everything we do kind of reinforces what we learned before. So if you didn't understand it before, well, you have another chance to understand it now. And yeah, that's all I have to say about that. So let's get started. Okay, so remember what revenue is. That's the amount that we take in from selling. Does not include our costs. It's just the amount that comes in that we take in. And we have a formula for that. It's price times quantity, which means if we fix the price, the function looks like this. It looks like P times Q. And we think of this as a function of quantity. So quantity is the variable. Price we're thinking of just as being a number, being fixed. All right, so then the price, notice that's the slope of this function. It's a linear function. P is the slope. So, and for a linear function, the rate of change is constant. So that's going to be the derivative of the revenue function. All right, that's the derivative, and that's what we call the marginal revenue. Remember what we defined marginal revenue before, the slope of the revenue function? Well, now we have a better notion, more precise notion of, slightly more precise at least, of the revenue function called the derivative. So that's the marginal revenue. By the way, definition of marginal, one definition is something of secondary importance, and yeah, I think it's a good definition, marginal revenue, because the first thing that we're interested in when we look at the revenue function is it positive or negative? But the second thing we'd like to know is it increasing or decreasing? So the second thing that we'd like to know is the marginal revenue. Anyways, I like to think about the definition sometimes. So let's look at an example. So let's suppose we're selling shoes for $50 a pair, and R is the revenue function for selling Q pairs of shoes. And so what would the revenue function and marginal revenue function look like? I've graphed them on top of each other here. So our revenue function is just price times quantity, and the marginal revenue is just the price. And notice that the revenue function, that's in dollars, the amount that we take in. The marginal revenue function will have the same units as the slope of the revenue function, which is dollars per item. All right. Yeah. And so we have a line with a positive slope, which means our derivative should be positive. Since that slope is obviously a constant rate of change, so then we'll have a constant function for our derivative. Rate of change is positive, so we have a positive function. Okay, good. So those things match up. And we also talked about the cost function. We talked about there are two parts of the cost function, the fixed costs and the variable costs. And so now we'll just define the marginal cost to be how much, to be the derivative of the cost function, which is how much the cost will increase as we increase production. Okay, same thing as revenue, just for cost. So let's look at an example. Keeping with the shoe example, now on the cost side of it, suppose we have a factory, it costs $500 a month to keep running, and I to be honest, I have no idea all the materials that you need to make shoes, but let's say you just need rubber, and it costs $20. It costs us $20 to produce a shoe. Okay, so then our cost function would be 20Q plus 500. And the derivative will be the slope of that function, which is just 20. Just 20. Okay. And notice that this y-intercept here doesn't affect the slope at all. Doesn't affect the derivative. All right. Whether I shift this function up or down, if I were to take this line and I were to shift it up or shift it down, it doesn't have any effect on the slope, does it? That ratio of change in y over change in x. So we only care about the slope when we're talking about the derivative. Okay. So we have a positive slope that's constant, and so we have a positive constant function for the derivative. Makes sense. Everything lines up. Well, these should line up. Slightly off, but anyways. Okay, so revenue and cost. Now we got those. We can talk about profit. And remember what profit is. That's like the net income. All right, that's the net result of revenue and cost. So we count revenue as a positive thing and cost as a negative thing. And we subtract those two things. So before we had 50q, and now we're subtracting the cost function, which was 20q plus 500. And make sure to remember to distribute your negative sign to both of these. And then you can combine like terms. And so we get the profit function is this. And how do you think we're going to define marginal profit then? We'll make it the slope of the profit function, which in this case is 30. Is 30. All right, so I've graphed those here as well. So the marginal profit is 30. And so here's what they look like, our profit function. Notice that this function actually has a negative bit to it. You're actually losing money until you produce enough to recoup your fixed costs. And after which you start gaining, have a net positive. Right? But the profit function, just because it's negative, that doesn't affect the slope, right? Whether you shift this function up or down, the slope is constantly positive. And it's the same slope at every point because it's a line. So the derivative will be just a horizontal line that's at a positive number. All right, so that's that. So another thing they like to do is this class is consider curves because revenue and cost function, they might be a little more complicated than a straight line, of course. So maybe you have this sort of situation, right, where the revenue function is this line here, the cost function is has a little curve to it. Okay, let's think about what's going on here. So I'm going to give you two ways to kind of conceptualize the profit from this. Because we're not actually graphing the profit function, we're going to graph the revenue and cost function on top of each other and visualize profit from the relationship between their graphs. So remember that profit is revenue minus cost. So profit is really this distance between the two curves. Because if you have some profit here, or some revenue and some cost at some fixed production level, then this difference in y values, or the space between the curves here, that will be the profit. And when cost is greater than revenue, like over here, then you have a negative profit. And also over here, you have the cost function that's higher than the revenue. So over here, for these production levels, you have a net loss, you might say. But over here, for these production levels, between about 25 and 100, the revenue function is higher than the cost function, and so you have profit. And we will have the most profit when this space is greatest. So over here, even though you have profit, the space is not that great between these two curves. So even though you do have profit, you have less profit than you do at a production level like this, where the space is greater. So see how the space reaches about a maximum somewhere around, I would say about 60, a production level of, let's see, 15. That would be about, I'm not sure where that would be. It would be somewhere around here, maybe. What would this be, 62 or something like that? Okay, so somewhere like 60, 65, something like that, is where I would say profit is greatest, because the space is the greatest between these two. Okay. All right, so that's that. And another thing that you might come across in your homework is not only are you asked to visualize profit in that way as like that space, in terms of the relationship between revenue and cost, but you'll also be asked to compare their slopes. And we can compare their slopes by looking at sort of the steepness of the curves. All right, so notice that revenue has a constant steepness, has a constant rate of change. Whereas cost is a little more complicated. It starts out kind of flatter, and then it sort of ramps up gradually in steepness. All right, so let's think for a second. So so we've talked about where profit is greatest, but how about marginal profit? Can we visualize that? And that would be by examining the relationship between the steepness of revenue and the steepness of cost. Because if the revenue function is steeper than the cost function, that means profit is increasing, like this bit here. Actually, all of this bit here. Everything to the left of about this point here, see how the revenue function is steeper than the cost function? That means profit is increasing during this bit. Now we're still practicing making the distinction between something increasing and something positive. So even though profit is negative over here because your costs are higher than your revenue, profit is increasing because it's becoming less negative as we move forward, right? The revenue function is steeper, so we're closing that gap of loss. And then we start going into the green as we go from 25 to about 60 or so. All right. Now after this point, from here about 60 onwards, the cost function overtakes the revenue in steepness. So notice that the cost function becomes steeper at somewhere around here. It becomes steeper. That means that from then on, the profit is decreasing. The profit is decreasing. Profit is still positive for this whole bit here. This whole bit, profit is positive because revenue is higher than cost. But profit is decreasing because as we move forward, the gap that represents profit gets closed. You could think about it like that. And then so the profit sort of evaporates as we go closer to a production level of 105, let's say. And then after that point, actually we're in the loss again. We're in the red. All right. So profit is decreasing from here onwards, even though it's positive from here up to about here, and then it's negative after that. All right. So that is that. So we would say that so profit is increasing all the way up to this point and decreasing after this point. And that's another way to understand the maximum profit, because profit is going up all the way up to this point, and then it starts going down. So in that sense, the maximum profit is somewhere right here. But that's what we said it was earlier, right? Because that gap is the highest. All right, so that's two ways to understand the same thing. but coming at it from two different angles. And depending on the situation that you find yourself in, you might find one way of looking at things more useful. All right, so that'll do it. That'll wrap up. I think that's the last section of chapter 2. So we will be moving on from now on. We will be doing more algebra, and maybe less graphs for a little while. So if you like algebra, if you like formulas and stuff like that, and there are some really simple, easy, some might even say fun rules that we will learn very soon. And so we will kind of, after this section, we'll kind of stop, take a break from graphs and things like that so much. All right. Anyways, that'll do it for now. Have a good day. All right. See ya. Goodbye.